Bismillahirrahmanirrahim. Today we shall talk about the third method of solving quadratic equations, that is, completing the square. Now some students are challenged by this method, but I think there's great beauty in it, and it's actually very important, as you'll see. So if I suggested to you this x squared equals 25, now you would agree this is pretty easy to solve. You would take the square root of both sides like this, making sure you put that plus and minus over there to give us two solutions. And then you would get x is equal to plus and minus 5. Or alternatively, if I gave you x squared is equal to 16, again here you would do the same thing. You would take the square root of both sides like this. And then you would have x is equal to plus and minus 4. Okay, now consider this one. Here we have the quantity x minus 3 squared. The whole thing is squared equals 25. Now you see the only difference here is still 3. Otherwise this equation and this equation here would be identical. So how do we solve this one? Well, the same concept really. You can take the square root of both sides like this. And here when you take the square root of x minus 3 squared over here, you'll simply get x minus 3. And on this side, you'll get plus and minus 5 again. Now this is like two equations in one. We can separate them out. This means x minus 3 is equal to 5, or x minus 3 is equal to negative 5. And adding 3 to both sides, you get x is equal to 8 here, and x is equal to negative 2. Okay, so just to be sure you understand, here's another one. This one states the quantity x minus 4 squared equals 16. See, this one over here is very similar to this one over here, where we had x squared is equal to 16. Now instead of x squared, I've replaced that with the quantity x minus 4 squared. Well, we do it the same way. We take the square root of both sides like this. X minus 4 is equal to plus and minus 4. Now you can turn this into two equations like this. X minus 4 is equal to 4, or x minus 4 is equal to negative 4 because there's a plus and a minus here. And then you can solve these by adding 4 to both sides. If you add 4 over here, you get x is equal to 8. And if you add 4 over here, you get x is equal to 0. So these are the two answers over here. Well, I don't know about you, but I kind of like this, kind of taking square root of both sides. But what if we have something like this? X squared plus 5x plus 6 is equal to 0. I kind of wish I could just kind of take square root of both sides, make my life easier or something like that. But that's not going to happen over here, because taking square root of both sides is not going to simplify anything. So I really wonder, what can we do? See, that is the concept of completing the square. The concept of completing the square is taking an expression like this and changing it to something that we wish for. That is a square like this on one side and something else on the other side. So that we can then take the square root of both sides like this. And then we can go about our merry ways. So again, the concept of completing the square is taking an expression like this, a trinomial like this, so that we can take the square root of both sides and solve the question. Okay, so I have rewritten the question here twice. The first time, I'm just going to solve it by factoring. And here it is. So the two answers to this question are going to be negative 2 and negative 3. Well, then you say, why don't we just use factoring to solve it? See, the thing is, not all quadratics can be factored. This one can be. How about this one? X squared plus 5x plus square root of 10 equals 0. Try factoring that one. Now, the merit of completing the square as a method of solving quadratic equations is that you can use it for any quadratic equation, even ones that look like this. Now we're going to use this to illustrate the technique of completing the square. Now, even before you start the technique of completing the square, there are two things to do. The first has to do with the first term, and the second has to do with the last term. This is like preparatory phase, so to speak. So in completing the square, the first thing to do is to make sure that this a is 1. And if it's not 1, you have to make it a 1. For example, if I gave you this, 2x squared plus 5x plus 16 equals 0. Now here, the a is 2. And for completing the square, we have to get rid of it first. So what you would do is you divide the whole equation, every single term, by 2, like this, even before you start. So here you would get x squared plus 5 over 2x plus 8 equals to 0. So the first step is to make sure that this first term here has a coefficient of 1. The second step here is to make sure that this c over here is on this side of the equation. So we have to get rid of this 6. Then you would have x squared plus 5x equals negative 6, like this. The first thing was to make sure the a was 1, and the second thing is to make some room over there. Now what you do is this. You take this coefficient here, and you divide it by 2, and you write it right over here like this. So what you do over here then, you take the coefficient and you divide it by 2. And then what you do is you square it like this, and then you write that over here. So that's going to be 25 over 4. But as you know, you can't just add stuff to one side of the equation. So whatever you do to one side, you must do it to the other side. So we add 25 over 4 also to the other side. Now, all of this here is kind of like our scratch work. It's kind of like, we're thinking through type of work so that we don't make any mistakes. What we're really doing is this. X squared plus 5x is equal to negative 6. What we're really doing is we're just adding 25 over 4 over here and adding 25 over 4 over here. Okay, now what you do is you write the parentheses like this. And then what you do is you take this x squared term and you write that over here as an x. And then you take this plus sign over there and you write that over here like this. And this 5 over 2 over here just falls straight down over here, kind of like an apple from a tree like this. Now notice, it is the 5 over 2 that falls, not this 25 over 4. And on this side over here, we simplify this over here and write it over there.
Okay, so this is heavy-duty math. This is negative 6 plus 25 over 4. You can't add them like that, right? So you have to make it a common denominator like this, right? So common denominator is 4. So the common denominator is going to be 4. 6 times 4 is negative 24, and that 25 over here. So this becomes 1/4.
And that's going to go right here. See, what we did over here is that we rewrote x squared plus 5x plus 25 over 4, and we rewrote that as x plus 5 over 2 squared. So we took a trinomial over here and we wrote this as a binomial squared. Because remember, we are doing all of this so we can in the end take the square root of both sides like this, because that's kind of fun. Now that also means that if you take x plus 5 over 2 and square it like this, and if you were to FOIL this, you would get x squared plus 5x plus 25 over 4. In other words, these two terms are identical. So the whole process was take a trinomial like this that could not be factored in this way and turn it into one. And now you see, you can take the square root of both sides like this. And when you do that, you get x plus 5 over 2 is equal to plus or minus square root of 1/4. Now this is simply plus or minus square root of 1 over square root of 4. And that is simply plus or minus half. I'm going to rewrite that over here. X plus 5 over 2 is equal to plus or minus 1/2. Now I can change this into two equations. X plus 5 over 2 equals positive 1/2, or x plus 5 over 2 equals negative 1/2. And I subtract 5 over 2 from both sides. Now this is 1/2 minus 5 over 2 like this, okay? So that's negative 4 over 2, and that is negative 2. So I get my first answer, x is equal to negative 2. And again, I subtract 5 over 2 from this side. Here I get x is equal to negative 1/2 minus 5 over 2. This is negative 6 over 2, which is negative 3. And I get my second answer, x is equal to -3. And as you can see, the answers are the same. X is equal to -2 and x is equal to -3. Okay, so let's just review. What did we do? First, I made sure that that was a 1, that the first term's coefficient was a 1. So that's cool. And then I took that 6 to the other side. That's the beginning of this method. So then I had x squared plus 5x equals to -6. And then we kind of did the circus maneuver, right? We took that 5 and we divided it into half, and then we squared it, and then we added that to both sides of the equation like this. And then we made this binomial expression, x plus 5 over 2. That 5 over 2 fell down right there, just like an apple from a tree. And then the other side simplified to 1/4. Now then it was the exciting part. We took the square root of both sides, like this. And that gave us x plus 5 over 2 equals square root of 1/4 plus or minus, and that was plus or minus half. And I rewrote that over here like this, and then solved the two equations. And as you can see, we got the same answers. Okay, as a review, I started out by giving some simple examples of quadratic equations. X squared equals 25, x squared equals 16. And I showed you how much fun it is to kind of take square root of both sides. And then I give you a slightly different example like this. And I said, well, here we can take square roots too. And then I made sure that you understood that we could do that. X minus 4 squared equals 16, and we took square root of both sides. And then I shared this one with you. Here we could not just take square root of both sides, although it was quite fun to take square root of both sides of an equation. Then we said, maybe I can do something. Maybe I can kind of manipulate this equation, that is, alter it somehow to look like this, where I have some quantity squared like this on one side and something else on the other side. Because then we could take the square root of both sides like this, and that would give us the answer. And that is the concept of completing the square. Until next time, as-salatu was-salamu ala rasulillah walhamdulillah rabbil alameen. Assalamu alaikum.